Title: Ants are making tiny chemical weapons. Intro. Right under our feet, a war is raging. Armies in the thousands are clashing, deploying sophisticated chemical weapons with brutal efficiency. The goal is simple: total annihilation of the enemy. But for one of these colonies, the greatest threat isn't the enemy at the gates. It's an invisible killer, a plague spreading silently from within. To fight this new war, they'll have to turn their weapons on themselves. And in doing so, they'll pull off a feat of medicine that took us humans centuries to master. Section 1. The External War. Deep in the world of ants, conflict is a way of life. It's a world built on chemical warfare, where territorial disputes aren't settled by simple brute force. They are chemical arms races, and victory goes to the colony with the most potent toxins. Take the infamous Argentine ant. These invaders have conquered 6 continents, largely thanks to their chemical arsenal. When they encounter a rival, they perform a maneuver called gaster bending. An Argentine ant curls its abdomen and precisely dabs its opponent with a chemical cocktail. The key ingredients, dolichodial and iridomyrmecin, cause immediate disorientation. But the weapon has a second brilliant function. Its scent acts as a chemical call to arms, rallying more Argentine ants to the fight for an overwhelming assault. It's a 1-2 punch that both incapacitates the enemy and calls in reinforcements. This strategy has been devastating, allowing Argentine ants to drive out native species and disrupt entire ecosystems. But some native ants are fighting back. Researchers made a remarkable discovery about the humble winter ant. When threatened, a winter ant secretes a tiny drop of a whitish poison from its abdomen. This substance is so toxic that a single direct hit is often lethal to an Argentine ant, with one lab study observing a staggering 79% kill rate. It's a powerful reminder that in the world of ants, even the smallest combatant can carry the deadliest weapon. Other species have developed even more insidious tactics. Slave-maker ants, for instance, raid the nests of other species to steal their young, who are then raised as a slave workforce. Some of these parasitic ants have evolved venoms that don't just kill, they manipulate. They can release propaganda chemicals that confuse their enemies and cause them to fight each other in a chemically induced frenzy. And then there's the fire ant. Their venom is a masterpiece of multi-purpose chemical engineering. Over 95% of it is made of piperidine alkaloids, most notably a compound called solanopsin. These alkaloids are powerful neurotoxins that cause the signature burning pain of a fire ant sting, but they're also powerfully insecticidal, capable of paralyzing and killing rival insects. From targeted assassinations to mass chemical bombardments and psychological warfare, ants have mastered every facet of conflict. Section 2. The Internal War. But fighting other ants is only half the battle. For a colony housing millions of individuals in close, humid quarters, the greatest enemy is often invisible: disease. Pathogenic bacteria and virulent fungi are a far more persistent danger than any rival colony. An infection can spread like wildfire, turning the bustling nest into a tomb. One of the most well-studied examples is the leafcutter ant. These are the farmers of the ant world, meticulously cultivating huge underground fungus gardens that feed the entire colony. But their crop is under constant threat from a parasitic mold called Escovopsis. This weeder fungus is specialized to attack the ant's food source, and an uncontrolled outbreak can destroy the garden and starve the colony. Living in such dense societies is a perfect recipe for a pandemic. Every forager returning home could be a Trojan horse carrying deadly microbes. This isn't a war fought with mandibles and acid sprays. It's a fight against an enemy that multiplies by the billion and attacks from inside the home. To survive, these colonies need more than soldiers. They need doctors, pharmacists, and public health systems. They need medicine. And amazingly, they find it in the most unlikely of places: their own arsenals. Section 3. The Unforeseen Solution. This is where things get really clever. The very same chemical compounds that make ants such formidable warriors also make them brilliant pharmacists. Their weapons of war are also their life-saving medicines. Let's go back to the fire ant. Their venom, packed with that potent alkaloid solanopsin, is a deadly weapon. But solanopsin also has powerful antimicrobial properties, making it incredibly effective at killing bacteria and fungi. Fire ants have been seen using their venom as a disinfectant, cleaning the surfaces of their nest to get rid of pathogens. Even more amazing, they practice a form of public health. Scientists have discovered that fire ants share their venom with each other through mouth-to-mouth feeding. Larvae, which can't make their own venom, are fed the substance by workers, effectively dosing them with an internal antibiotic that protects them from infection. The colony's deadliest weapon is also its most important shared medicine. This dual-use chemistry isn't unique to fire ants. Many ant species have specialized metapleural glands that secrete a whole host of antibiotic chemicals. The ants meticulously groom these secretions over their bodies and throughout the nest, creating a chemical shield against infection. The evolutionary arms race against other insects inadvertently gave them a sophisticated defense against microbes. Perhaps most remarkably, some ants don't even make their own medicine, they outsource it. In their fight against the Escavopsis fungus, leafcutter ants have formed an ancient and vital alliance. Living on the ant's body is a species of bacteria, often from the genera Pseudocardia or Streptomyces. These bacteria produce a powerful cocktail of antibiotics. When the ants detect the parasitic fungus in their gardens, they wipe it away and then inoculate the area by rubbing their bacteria-coated bodies on it, applying the antibiotic exactly where it's needed. It's an incredible symbiosis. The ant provides a home for the bacteria, and in return, the bacteria act as a living, self-replicating pharmacy, protecting the ant's food supply. Conclusion. The intricate dance of chemistry reveals a profound truth about ant societies. They aren't just mindless drones. They are masters of a complex chemical world, waging war on two fronts at once. They use toxins to conquer their enemies, and at the same time, use those same toxins, or cultivate symbiotic microbes, to protect themselves from the constant threat of plague. So, the next time you see an ant, remember you're not just looking at an insect. You're looking at a master chemist. A warrior armed with toxins capable of taking down enemies many times its size, and a physician carrying a pharmacy on its body, able to sterilize its home and cure its sick. They are a testament to the brutal, beautiful, and endlessly inventive power of evolution. Thank you for joining me tonight on Night Chemistry. I hope you enjoyed this quiet journey into the secret chemical world of ants. Nature hides so many stories, and each one is a reminder of how extraordinary life can be. May your dreams be filled with curiosity, wonder, and calm. Sleep well, and good night.